Good morning to one and all present here. It gives me immense pleasure to welcome you all to the 5-day faculty development program on design challenges in antenna and RF devices for generation communication. On behalf of the organization committee of EC department of PSNSET, I extend a warm and heartfelt welcome to all the dignitaries, resource persons, faculty members, researchers, and participants joining us today. In today's rapidly advancing wireless era, technologies such as 5G, 6G, IoT, millimeter wave, and satellite communication demand innovative antenna and RF design. This FDP has been carefully planned to address these emerging challenges and to enhance both academic and research perspectives in this vital domain. I kindly request our HOD Dr. D. Rajesh to deliver the welcome address.
Good morning to one and all. It gives me immense pleasure to extend a warm and heartful welcome to the Chairman, Vice Chairman, Executive Director Dr. P. Selvakumar, Principal Amida Shirgil, Resource Person Dr. V. Karthikeyan, ASP, EC Department, MEPCO Engineering College Sivakasi, faculty members and participants to the Faculty Development Program on Design Challenges in Antenna and RF Devices for Next Generation Communication. Faculty Development Program play a vital role in enriching teaching practice, strengthening research orientation, and keeping us aligned with the rapidly evolving academic and professional landscape. We are truly honored to have with us our esteemed research person, where expertise and experience will undoubtedly inspire and guide us throughout this program. I also extend a sincere welcome to all participants who have taken time from their busy schedules to be part of this initiative. I would like to express my gratitude to the organizing committee and all those who have worked behind the scenes to make this program. Once again, I warmly welcome you all and wish everyone to productive, engaging, and enriching faculty development program experience. Thank you.
Thank you, sir. At this moment, I invite Dr. Kavita, the FTB coordinator, to brief us about the objectives and structure of the 5-day program.
Thank you, ma'am. I am excited to share the highlights for the 5 days FDP in design challenges in antenna and RF devices for next generation communication. These next generation communication systems operate across wide frequencies from millimeter wave, terahertz frequencies to microwave frequencies, posing new challenges in antenna design. It demands low power devices, advanced materials, and sophisticated simulation and measurement techniques. Speakers from industry and academia shares insights on emerging trends like reconfigurable intelligent surfaces, metamaterials, etc. This 5 days FTP aims to provide participants with a comprehensive overview of antenna and RF device technologies, covering both fundamental concepts and recent research trends. And I also want to share to the participants. E-certificates will be shared for the participants who attend all the sessions. Feedback link will be shared at the end of the last day session, and also an assessment will be conducted at the last day session. So hereafter, I hand over the session to Dr. Karthikeyan to proceed with his session.
Karthikeyan, sir.
Thank you, ma'am.
Thank you for the clear overview of the program. Before we proceed further, I would like to express our sincere gratitude to all those who made this event possible. Thank you. With this, we formally conclude the inaugural session. I request all the participants to kindly proceed with the first technical session of the FDP. Thank you all and wishing everyone a very informative and successful FDP.
Okay. Ma'am, may I start?
Yes, sir. Yes, sir. You can start.
Okay. Thank you, everyone. And initially, I want to thank the management and the principal who wholeheartedly organized this kind of FDP in that current scenario, like design challenges, antenna and RF devices, and the next generation communication. This it is an interesting topic, and next generation communication along with the 5G, 6G towards we are moving towards the 6G. It may be operated towards that end of Bharat vision, and this is the trending scenario that can be identified, and many faculties, those who are doing PhD, that may be a scenario that interlink your communication along with the AI, and that may increase the overall research productivity as well as that overall communication that is going to be participate, and overall improve the enhancement of faculties coordination. And initially I thank the management and the principal as well as the convener
Sir,
of.
1 minute.
Yes, ma'am.
We will give a brief introduction about yourself before you starting the session.
Okay, okay.
1 minute, sir. 1 minute. Mariel, ma'am.
It's my privilege to introduce our resource person, Dr. V. Karthikeyan, a distinguished expert in the field of antenna and RF engineering, whose contribution to research and academics is truly inspiring. Dr. V. Karthikeyan is an accomplished academician and researcher, currently serving as an assistant professor, senior grade in the Department of Electronics and Communication Engineering at MEFCO Select Engineering College, Sivahasi. He holds a PhD and brings with him over 16.6 years of combined R&D and teaching experience, along with 2 years of industrial experience, making his academic insights strongly aligned with real-world applications. His area of specialization include image and signal processing, soft computing, and Internet of Things. Dr. Karthikeyan has made significant research contribution evidenced by his strong scholarly presence with the Google Scholar High Index of 9 2010 citation and a Scopus High Index of 8 142 citation. He has published extensively in high impact Scopus and Web of Science Index journals, including the Visual Computer Applied for Computing, Pattern Analysis and Applications, and Computer and Electrical Engineering, with several works focusing on deep learning, CNN architectures, attention mechanism, and voice recognition. Dr. Karthikeyan is also an award recipient, recognized as an NPTEL domain scholar and GATE scholar. In addition, he holds multiple published patents in areas such as smart wearable device, voice control system, accuracy tracking, and antenna design, highlighting his strong inclination towards innovation and applied research. With his rich blend of academic excellence, research expertise, and innovation-driven mindset, Dr. V. Karthikeyan is an ideal resource person to enrich this faculty development program and provide valuable insights to the participants. Now, I request Dr. Karthikeyan sir to take over the session. Thank you, sir.
Thank you, ma'am. Thank you for my broad introduction. And with my humble acceptance of your introduction, I am going to start the session. And initially, I thank the management and the principal who supported this kind of FDP to faculties and to enhance their knowledges towards that 6G scenarios, those who are going to be handled in the smart city, as well as your intelligent speech processing applications, and that may hand over the next generation communication. And next, I thank the convener, Dr. Rajesh sir, and the coordinators, Kavita ma'am and Marial ma'am, those who have contacted me regarding that the first session I'm going to start at today. And it will be the interesting scenario, and we are moving towards the Bharat 6G vision, and it may be hand over to each and individual person at the 2030, and that has the scenario of that has the vision of terabits per second application data transmission speed, and the latency, it will be sub milliseconds scenario, and along with the communication they are going to incorporate AI, and they are in that testing scenario in order to hand over that 6G in a in each and individual Bharat people in and around 2030. And that along with the AI integration, that will have one more support called intelligent reflector surfaces, that is IFS. And along with that, they are going to provide that digital twin scenarios. Okay. And Department of Telecommunication, they are in the mission of 6G, and they have incorporated three main scenarios to match up with the International Telecommunication Unit. That is one which will be ISEC, that is of integrated sensing as well as communication. That environment is sensing before the communication is happened. We need to sense the environment. The environment will be an open air environment that may create interference or noise to our overall communication system. So before communication, we have to sense the environment to avoid that noise and interference suppressions. And second will be non-terrestrial networks. Instead of considering the earlier terrestrial based access scenarios, we are moving towards the non-terrestrial based access scenario in order to improve the overall throughput as well as the latency reduction scenario. And the third scenario main will be of native AI. Along with the integration of AI, we have to go for native based scenarios. Okay, so these are the main scenarios for the Department of Telecommunication. They have considered for the incorporation of Bharat 6G vision. So I'm going to share my screen now. Ma'am, I couldn't able to share my screen now. Could you allow me to? Kavita, ma'am?
Yes, sir. Yes, sir. You can
Allow me to share my screen now.
Yes, sir. Yes.
So my topic is speech signal processing using modern AI approaches, and why it is predominantly needed towards the antenna and RF devices, and that thing I'm going to discuss here. And speech, when we go for a speech, it is a direct carrier language, or we can say it is a conventional way of communication among human beings, and it is a key part of information transfer, what is happening among your day-to-day life. And with the growing development of each and individual technologies like AI and your overall support of AI with the telecom and sensing devices and so on, we can incorporate these technologies to a speech related communications and speech recognition technology, which is carried out using your handheld devices like computers, cell phones, tablets. And by the way of rapidly growing technology, we can incorporate these along the things with support that may provide a overall integrated speech processing or intelligent speech processing application. So it is the hidden agenda or hidden information that may add it along with your overall scenario. So I'm going to share my screen now. Now is this visible?
Yes, sir. It is visible, sir. Yes, sir.
Okay, this is my topic, speech signals processing using modern AI approaches, and these are all the agendas I'm going to handle. And initially, we are going to see what is the fundamental scenarios of your speech signals and what is the classical digital signal processing pipeline. And now we are instead of classical DSP pipeline, now we are moving to a neural representation. We are mainly the things we are going to consider: wave to vector scenarios and Hubert scenario, that is a single standalone self-organization scenario, and wave LM, it is a non-supervised scenario, and end-to-end automatic speech recognition scenario. What are the things conventionally these days they are using? And speech processing generally classified into speech conventional ASR, automatic speech processing scenario, as well as speaker recognition scenario. The speaker recognition talks that may be of recognition as well as diarization, and how it is enhanced, and as time text to speech conversion, how it is happen, and speech to text conversion, how it is happen, what are the metrics they need to consider. And finally, we need to handle the ethics, because why we go for ethics, we are directly handling the data from the each and individual person that is directly related with the individual personal information. That's why we need to follow the ethical rules and regulation while we are going for speech related works. Conventionally, what is meant by speech signal processing is, when we go for the definition, it is mean by analysis, transformation, understanding, and it is transforming your speech information for using a computational scenario, or that using your general conventional analysis system that is going to analyze your information. Based on the analysis information, it may convert your overall speech into a text, or you are enhanced your scenarios, or you have to remove the noise and interferences in your scenario. What is the conventional things, what is happening in speech signals? So what are the core tasks that may be incorporated? That will be automatic speech recognition, that you can see or the speech will be recognized, and based on the speech recognition, that may be converted into a text, or and text will be converted into speech to text, and text to speech conversion that may be happen. And speech enhancement, that in that scenario we have to remove the license non-vocal portion, as well as your or we can say it is a scenario where your lies, your instead of voice section, we may have non-voice section also available. That non-voice section removal, that may enhance your overall speech recognition, that will be there when we go for speech enhancement. That is one scenario. And source separation, that we have to separate the source with the background. A background means the environmental information that may add with your original source information. That separation, that may improve your overall recognition of your speech. And speaker recognition, it will be classified into identification as well as verification. Identification, it is a binary level. It will verify whether the particular speaker is X or not. And verification, it will identify the label, what is the exact person label. Based on the scenario, it can be applicable for that identification, that authentication scenarios. And why we go for your speech signal processing nowadays? Because speech will be of massive amount of data will be there. The data will be processed using incremental amount of your processing powers. And when we go for your scenarios, it may be a supervised or non-supervised, or your autonomous scenarios that can be used for the learning purpose. And these can be incorporated with the AI, modern AI approach. So there we can apply these speech signal processing. It may be a virtual assistance, or your real-time captioning, or we can go for your speech-based audio, dialect-based activation scenarios, and multilingual communication. There you can incorporate. Okay. So in your earlier 1950s, and that key technology that is used in your speech signal processing is syllable recognition system. And that recognition system specifically applicable only for speech conversion scenarios. So it will be, what are the difficulty they have considered is when we go for your diarization or enhancement or your source separation scenario, that cannot be used. When we go for your 60s to 70s, it will be of your rule based or statistical modeling they have incorporated for speech communication. And it is a continuous speech they have considered. In that earlier scenario, distinct speech only they have considered. In that scenario here, we have considered a continuous speech. So recognition of speech that may be increased, but they didn't consider the noisy environment. And when we go for to 80 to 2000 scenarios, deep learning techniques as your neural network model try to increase or try to compensate. So the complex speech patterns they have tried to analyze, and from the complex speech patterns, they are going for an automatic learning capability they have tried to implement. And in that 21st scenario, 21st century, they have used modern internet as well as smartphone penetration that may increase more and more amount of your speech data. That data will be are processed with the help of your high-speed GPUs. That GPU that may incorporate to provide various kinds of application in real-time applications. So speech production mechanism, it will be classified into three scenarios. Source filter model, in that lungs will be an initial source, and in that scenario, here that air molecules that is enter into our lungs, that will provide as an excitation source. And when it is passes through a vocal tract, that is a time varying filter that may create different kinds of sounds. And when we go for your speech along with the vocal, we have to go for ear for perceiving your voice. These two things will be combined together and provide your overall speech production mechanism. So your time varying vocal characteristics that may create different form and frequencies that will represent each different speaker characteristics. When we go for human auditory system, that will identify the pitch as well as the loudness as well as the band of frequency where that pitch align, and based on that we can find out the Mel frequency scale or your conventional Mel frequency spectral coefficients of your features. So finally, we need to find out the various dialects, what is inferred or collected from the particular persons, and that will be transferred to a brain for your overall processing. And for final, once it is analyzed, based on that overall input, it will provide a necessary action, whether it is identify the particular person or to identify the word, what they are spelled, and what is the emotion of the particular patient and everything. Okay. So this is the conventional speech production mechanism. So when we go for your sampling scenarios, when we go for telephony application or your outdoor environment, we have to go for the sampling rate of 8 kilohertz. And when we go for your wideband indoor environment, it will be 16 kilohertz. And with these much of samples available, so many inputs or your many more informations will be there when we go for your speech data processing. And then it is applied to a quantization scenario. It may be a 16 PCM or 64 PCM we can implement. That much of quantization levels we have to incorporate. After quantization, it will be applied to ELA, MULA compounding for the efficient incorporation of data that may remove the redundancy in your overall speech information. Then it is applied to a file containers. There we have to go for your compression, that may be a lossy or a lossless compression. And when we go for dot wave based scenario, that will be uncompressed PCM, that directly the quantized output will be restored there. And when we go for your MP3 as well as your conventional lossless compression scenarios, we have to do another kind of operations before storing. So it is the classical DSP pipeline. So initially it is applied to a pre-emphasis circuit, that is a FIR, a finite impulse response filter. Here we are preferring high pass filters that will always increase your signal to noise ratio as well as your compensation where your spectral delay is happening. Then your pre-emphasized data will apply to a framing scenario that will be divide your overall input speech into a frames of your non-overlapping as well as your overlapping sections. Then it is applied to a Hanning window or Hamming window to filter out your overall components. Then for the E10 individual frames, short time Fourier transform is applied, and that features is extracted. Once that features is extracted, that is applied to a normalization, and finally we'll get the overall data about the particular speech. So when we go for your framing as well as windowing scenario, typical configuration or your conventional speech processing always that may require 25 milliseconds frame and each with the 10 milliseconds hop. And the frame may be a overlapping one that will provide a overall temporal extraction as well as your speech pattern is tracking of your original source. So then it is applied to a windowing, Hamming and Hanning windows of your FIR that may be preferred, that provide a main lobe of higher width, and that suppression, side lobe suppression is very much high. So we are in that speech processing scenario, Hamming as well as Hanning is preferred. And then we have to prefer voice, we have to separate your voice as well as non-voice section. The voice as well as non-voice section can be easily classified with the help of voice activity detector. That voice activity detector identify the pitch portion, and from the pitch formant frequency, from that around area we have to cover that bandwidth of the particular first formant. From that scenario we can identify the voice as well as non-voice section. So it is a simple diagrammatic representation of spectrograms. So spectrogram is nothing but your continuous short-time Fourier transform collection of your overall message or speech. And what is spectrogram or your it is the frequency domain representation of your magnitude as well as phase components. And time, we can say it is a frequency domain resolution representation. Okay. Short time Fourier transform, it is we are going to use, it is a short time as well as overlapping windows we are going to use to get back your frequency domain characteristics of your speech informations. And what are three main things that may affect your overall spectrum? What is the size of your FFT you are choosing, and what is the hop size or your resolution of your time that we are consider, and what is the window type we are consider. Okay. And in your hops you may consider if you are increasing more hops means that may provide a poor resolution. Okay, so we have to choose these parameters in an efficient manner or in a dynamic manner to provide a better input extraction from the source side. And when we go for your amplitude as well as your phase spectrum, phase always it will provide a signal when we go for your reconstruction of your original speech, what is transmitted from the source side, that phase always need to be or your correlate with your amplitude in such a way that it will not create any phase variation in a receiver side. So one of the main features that we have conventionally used in our speech communication will be bell frequency substral coefficient that will be used many of the researchers in their own works like your speech processing, speech diarization, speech to text conversion or text to speech conversion. These will be the predominant features they have considered. So what is the bell frequency spectral coefficient? That is one kind of your short time Fourier transform only, but along with the short time Fourier transform, or FFT, we have to consider one more thing, log of that particular nature. So initially we have to go for pre-emphasis and then we supply to a fast Fourier transform application, and conventional fast Fourier transform size we have to choose. Then it is applied to a MEL filter bank that will have a group of filters that may contains 20 to 40 filters that may extract your low frequency as well as high frequency components. Then it is applied to a log for the compression percept. It is compressed based on the perceptual compression. Based on the audio nature, it may compress. Then it is applied to a discrete cosine transform. It may decorrelate your components and it may extract 13 or 19 coefficient based on your user requirement. This is the conventional MFCC component. So along with the MFCC component, you may extract your velocity as well as the acceleration component that will be called as a delta as well as double delta. So these will represent delta will be the first order coefficient of MFCC, and delta will be the second order acceleration parameter of your MFCC. Once these parameters are extracted, these parameters will be applied to a learning scenarios there they can learn about the input source speech. So then filter banks, initially I have mentioned it may be a 20 to 40 filter banks that may use. It is a log bell frequency banks that will represent or re-establish the speech pattern what is inferred from the source side. And when we are used more and more filter banks and compression that may not reduce the overall speech quality. And initially prosodic features that may consider the fundamental frequency that is of your pitch, and along with the spectral energy distribution as well as your rhythmic of your pattern as well as your spectral soundness that can be identified with the help of your prosodic features. And it will be very much crucial when we go for your TTS as well as STT, speech to text as well as your text to speech conversion scenarios. And where it may use different algorithms to capture your pitch informations, and some of the algorithms will be Eden algorithm as well as your creep algorithm for your robust F naught estimation. Even though your environment that may change, your these two algorithms efficiently track that F naught. So now we are moving to initially these are all the classical scenarios. Now we are moving to a neural scenario because your AI, modern AI approaches, how it is incorporated along with your conventional one. So initially it is going for the representation level. So initially we have to go for your handcrafted features to learn about your input source audio or your spectral information. So it will be a domain-based knowledge always necessary. And when we go for your particular specific task, that task only that decide the overall block of the work. And the resource availability is always very much limited one, and the robustness, that stability of the overall proposed work is always limited one. When we go for your neural network approach, it is the end-to-end based scenario. When we go for learning, training, everything will be happen in a single architecture. And it is a data driven application. Your data is infinite source of data is available. So based on your input data, it will learn. Based on the learning, it will activate the overall control actions. So self-supervised learning that may incorporate wave to vector scenarios or your Hubert scenarios that may handle more than 90 millions of your data and from the data it may collect the information about your source speech, and based on that it will activate. What are the activation models you can incorporate? ASR, that is automatic speech recognition, speaker recognition, or you can learn the emotion. And that emotion recognition nowadays may utilize in many yeah, in biomedical applications like remote patient monitoring based on the emotion of the particular person, even though they didn't show the particular input about your medical condition scenario. Even though their emotion is changing, means based on that also it can activate the system, and that particular caregivers or your doctors may be initiated to activate or your to check the person's conditions. Okay, these are the things in nowadays it has happened. So now we go for your neural representation. First one is your wave to vector representation. It is a self-supervised scenario. It will be trained on a raw input video, raw input speech informations. So that will be applied to a convolutional feature vectors, and that will be seven temporal convolution layers. Continuously, it will learn from the raw audio data, and the stride size initially it will be 5 cross 5, but is now it can be moved to a 3 cross 3 scenario for your GPU related application. Then it is applied to a transformer context network. There you have to calculate your overall receptive fields as well as your overall context-based information about the particular raw audio data. Then it is applied to a vector quantizer as well as context vectors to discretize your code as well as your and your pre-train your network in a fine-tuned manner to achieve your labeled information. So these neural wave to vector always we can prefer when we go for your labelized data. When the labeling is available, based on that you can train your model, and when we land into a particular minimal loss function, then we can stop the function, and that particular frame is taken out, and then that is applied for a speaker related information extraction. Then second scenario will be a Hubert's information. It will be a masked prediction, and it is a cluster based scenario. So when we go for a cluster, it is a non-supervised scenario we are preferring. So we have to form a clusters of your different size, or your k-means will be a best scenario. So based on the MFCC inputs or your filter banks input, different clusters are formatted, and that cluster informations are once again that is applied to a iterative refinement, and then it is applied to a transformer encoder for your learning of your data. Based on the learning, it will calculate that cross entropy loss. If the entropy loss is reaches to a lowest possible minimum capability, then it will stop. Otherwise, it will be once again re-informed to a reclustering formation. It is repeated more and more until it is satisfied a particular performance criteria. So it is the work of your qubit. And second, next will be of your wave LM scenario. So it is a unified pre-tanning scenario that denoising everything will be along with the denoising we have to do for another kind of scenarios like speech recognition, and speaker recognition scenario. So we can denoise your application, your source side noises as well as your environmental noises. So the robustness of the method is highly more. So nowadays, that's only your natural language processing. Most of your NLPA scenarios, LLM will be the best scenario they are incorporated to obtain improved or your boosted performance. So when we go for your recording or input of your speech signal, that your overall noise as well your speaker overlapping of your speaker overlapping happens in your frames, that may affect your overall performance. But it wave LM that may reduce these kind of scenarios with the help of your transformer encoders. And next will be now these are the earlier three applications like Hubert, WaveLM, and your wave to vector. These are all your individualistic applications, and then initially that may apply to a feature extraction or learning or classification or your speech to text conversion, or that scenario individually that can be used. But when we go for your end-to-end scenarios, all the things that can be done in your individualistic framework or your model. So conventionally initially start with the end-to-end ASR. So that will be initially start with the cities. So before enter into a end-to-end scenario, initially you have to learn what is supervised learning. So what are the deep learning approaches or your AI approaches that can be used for your supervised approach? So using your labelized data or your information, you have to train your model. So the model will be mapped to a particular scenario where the particular label should be matched towards the particular training of the model. Okay, so we can say it is mainly mapping your speech signal to a text information. So what are the conventional AI approaches we can use? Either deep neural networks or your LSTM based scenarios or your connection list temporal classifications, RNNs, recurrent neural networks, hidden Markov models that can be employed as your supervised models. So they can optimize the performance, but labelization is mandatory. When we go for your unlabeled data, that may provide some difficulty in overall performance training as well as learning. When we go for your self-supervised learning, unlabeled speech data will be given as the input, and based on the speech pattern as well as representation, that assistive networks what we are using that may learn or provide a particular overall information about your source speech. So it is called, we can say, GAN-based scenario. Your generative adversarial networks, self-encoders, transformers that may use in these scenarios. So it may not record any layer-based data, but complex model structures always take more and more amount of computational load as well as your time consumption. So semi-supervised learning means it will be contain both labelized as well as non-labelized. That is of your clustering based scenarios. Okay, in your within your cluster we can go for your labelized scenario. Outside the clusters we have to go for your non-labelized scenario. So that is the thing we have seen in your Hubert. So these are all the things when we go for your recognition as well as your learning of your overall speech data. So when we go for your end-to-end automatic speech recognition, connection list temporal classification, it will classify frame level alignments. Okay, so it will use a blank symbols to handle your overall length, and when it is aligned in a proper manner, and it will be matched with the acoustic frames, and that will be variation whenever it is shows a variation. The particular character is not mismatched with the overall input what is arrived from the source means it will realign the pattern to minimize that word error rate as well as character error rate. Until that, this problem or this scenario will be repeated. And what is the main limitation of this work is we have to give a separate rescoring scenarios or reordering scenarios in order to match your acoustic frames. That may take computational load more and more. And next will be of your recurrent neural network based scenario. So audio chunks, your input will be divided into chunks or your frames, and that will be applied to a LSTM based encoder scenarios. So it will be streamline your overall inputs, and then it is applied to a over conventional main architecture that is of your conditional deployment as well as your joiner prediction network. That in that prediction networks we will predict what is the next chunk we have to realign in such a way that it will provide a clear information of text to speech or speech to text conversion scenario. When we go for your speaker recognition, it will align the feature mapping scenarios in order to match the pattern of the original or your the intended speaker pattern. So it will match the patterns of already stored one with the applied or received one in such a way that it will verify the authenticity of the particular speaker. So it will be this scenario. It is used in main or your various application of your smartphones for your speech oriented activation as well as your speech related control applications. Then we have attention as well as transformer based scenario for automated speech recognition. the transformers that may act as a encoders as well as your decoders that will compress your overall information. So when we go for your lightweight models as well as your smartphone based implementation scenarios, this will be the best scenarios that may incorporate along with the attention scenarios. So attention scenarios, it will provide or minimize the feature what we have to apply for the training or learning of the model. So when we go for attention, that name itself that shows we have to give attention to certain features or certain scenarios. Okay, so it will combine with the convolutional input obtain convolutional block that is obtain raw features or learning from the overall information. It will apply self attention to capture both global as well as your local attributes of the particular raw input data. So these patterns that may minimize the loading as well as the learning time models taken from the conventional models. Okay, so these incorporation, these attention with the transformers, attention with the language models, that may improve the overall performance of the ASR system. So Whisper, when we go for earlier scenario, that is of your transformer, that we cannot go for your large scale applications. When we go for your large scale scenarios, we have to go with the extended version of your transformers. So so we conventionally audio input, we have to get taken that log mel spectrogram. So along with that, we have to add the prosody features as well as your temporal features in order to go for your kind of large scale automatic speech recognition application. When we go for your multilingual, along with the speech recognition, we have to go for speech to text conversion. We have to go for speech diarization or speaker verification. Then we have to go for these scenarios. Okay, to a single architecture, we have to do more and more applications. In that scenario, we have to go this one scenario. So one is, they have mentioned here, it is a multilingual one. Multilingual, instead of considering for the architecture for one language, we have to go for more and more languages. So we have to go given more data to learn. So transformer itself, it may take more than 90 billions of data. So it may take for an individual language, we have to go or input more inputs. So when we go for your robustness of this large scale models, we have to analyze or verify that performance in a noisy environments and various dialects, accents, as well as your speaking styles, patterns, and environmental information variations, and language detection model variation, and your Margot models also incorporated to verify the statistical nature of the input what is arrived from the source side. And we have to verify the voicey as well as non-voicey section separation. It has to be done in an efficient manner to provide the overall text output is the exact match one. So next will be of your speaker recognition. Speaker recognition or identification is nothing but your conventional binary verification. So it will verify that particular person is X or not. When we go for your verification, it will find out what is the exact person label or name from the consider it may be 100% input. I am 100% input I am given to a system that will learn and verify what is the 85th person name. That is it is the exact match that is identified from the learning of the system. Okay, so it is the here it is considered two things. Identification as well as verification. So it based on the similarity of the information what is that features what we are obtained from the particular source speech, it will collect the pattern and store it in the training side. When we go for the testing scenarios, it will collect the samples or the features from the input speech and map the particular testing features with this already obtained trained features. From the similarity scoring scenarios, it will match and provide the final label or whether the particular person is verified, correctly identified or not. Okay, so this is the scenario where we can employ for your personalization device based when we go for your voice-based activation of your control inputs and your diarization as well as your forensics application, the particular crime scenarios it is taken place, whether it is a already existing pattern or the particular person is already the criminal record is available, means based on that we can easily track that person. So these are all the applications. Then we have to move for an important one, that is speaker diarization. So in the diarization we have to verify the particular, when we are getting a overall information from the particular source side, we have to speech activity or voice activity is detected, and based on that we have to segment your dialect section into a voice section alone. Then it is applied to a extraction of your features, and that is X vectors as well as your TDNN approaches are applied to your extract your speaker identity. Once it is identified, so that is map or cluster into form when we get a group of information or a group of speech signal, that will be grouped into individual clusters. So from the diagram you can see we are getting a more audio streams that is combined with the different speakers. So once it is identified a particular speaker, so that speaker alone it is clubbed together to form one cluster that will be act as a diarization of the particular speaker. Okay, so these kind of scenarios we have to diarization error rate will be a evaluation measure. Based on the diarization error rate, we have to cross verify or verify the overall performance of the system, AI system what we are implemented. Then we have a speech enhancement as well as noise reduction scenario. So classical approaches, conventionally, they may use some filters like VNR filters, your Kalman filters to minimize the mean square error what is happened in your conventional noisy system. When we go for your statistical or your static approach or your static scenarios, that may provide a best one. When we go for your dynamic environments, the environment criteria is dynamically adaptively changing, means there we have to use your deep learning based or your AI based approach that may provide a better scenarios rather than the static one. Okay, so here GAN based scenarios or your diffusion scenarios, we have to incorporate along with the original models to learn the environmental noise conditions, and based on the noise condition it will adapt the AI network parameters to filter out that background noises as well as your source side participator noises. So this will be minimize the overall when we are when we pre-process the data or eliminate the background information. It is easy for the particular AI tool to learn the particular speech information and provide a overall record output with the reduced computational cost. Now one more application is source separation. It is applied way to separate whenever to multi-model in multi-speech information is collected, and from that we have to separate the individual work, means we have to go for source separation scenarios. And it may be temporal convolutional neural networks as well as encoders, dual path architectures, and your transformer based scenarios with attention that may be used as a source separation. Here signal to distortion ratio as well as your training and PIT, that is of your permutation invariant training, that may be used as a performance metric to analyze the overall performance of the system. Text to speech synthesis, here we need to give the speech text and information, and for that text information it may create a acoustic model, and it will recreate that vocal track of the particular human speech production mechanism. So based on that vocal track mimication scenario, it may create voice spectrums or your spectrogram inputs are generated, and based on that it will match the overall text what is given as the input. So that in that scenarios, wave to net as well as wave glow and hi-fi GAN, these are all the AI approaches we can use for this kind of applications. And mean opinion square and prosody-metrics will be the, because we are generating a speech, f naught will be matched with the conventional one in order to reproduce your overall speech. Then voice conversion as well as cloning scenarios. Your source or audio will be applied to a overall voice conversion model, so that we can see in your in nowadays multimedia applications. So it will match with the existing pattern and reorder our pattern in such a way that your target speaker voice pattern is matched with the original applied input pattern, and content as well as dialects as well as speaker models that mean match, and that will produce the output as a converted audio that is of cloning of your original targeted one. So this will be the scenario they may used to thread your overall fake the voice fake scenarios. Okay, so anti-spoofing based applications that may identify these kind of cloning is whether it is happening in your system, that you can find out. So when we go for automatic speech recognition applications, word error rate as well as character error rate will be the evaluation measures. So when we go for your word error rate, n represents that total words. When we go for character, it is characters, number of characters. It is calculated based on that. It will find out the performance measure. So in that bottom, you can find out for the same same input scenarios, what is the word error rate as well as your character error rate scenarios. Whenever your error rate is very much low, that shows a better performance. Sorry. When we go for your quality of your speaker metrics, your perceptual evaluation to speech quality, debt curves will be of your main thing for your speech, automatic speech recognition applications. And EER, equal error rate, will be the performance measure for your speaker verification as well as identification. And MinDCF also we can use for your speaker verification as well as identification. When we go for your authorization based scenarios, EER as well as MinDCF will be the best evaluation measures. That may initially they have considered false acceptance as well as rejection rate as well as in that evaluation or identification of the particular metric. So these are all the key database as well as benchmarks, open source data sets available. When we go for automatic speech recognition, Librich Speech, TED Liam, and WSJ, these are all the open source data sets. And when we go for speaker recognition, Voxelab 1 and 2, NIST, and your fisherman based data sets, and these are all things openly available. AMA meetings and your particular Nelson Mandela's speech conversation for a longer period of time, that can be used for your identification scenario. These are all the things, it is openly available. And when we go for text to speech conversion and voice conversion scenario, LJ speech, that will be the open source available. And when we analyze the robustness of the particular method, we have to go for CHIM based challenges, CHIM challenges and Aurora challenges. And finally, deployment, where we can deploy or use your overall application is, we need to consider processing power as well as speed as well as load, computational load. Then we have to minimize the latency what is happening in your conventional system, and the model should not create any complexity in your overall application, and accuracy level that should be always high, and based on the use case scenario where it is deployed, that also you have to identify. So final thing, always you have to follow the ethicals and privacy, because we are going to use the speech of each and individual person. So you have to follow some rules and regulations. Beyond that rules and regulation, you should not violate the privacy of the individual persons. And spoofing, that is, I have mentioned, it is replicating or your voice patterns, what is the individual persons. So spoofing, you have to, that will be used in your forensics application. You have to identify whether it is a spoof data or anti-spoofed data. So these are the things we have to follow, the rules and regulation of individuals one. So this is the one hands-on, or you can try by your own. It is a Librosa based things. I have taken the speech waveform. So from that I have applied a feature extraction. For my things I have taken Mel spectral features, and then it is applied to a ASR model. So I have considered that auto processor model, that is of wave to vector transformers. Once it collected, the learning of the things will be happened, then it is applied to a final extracted feature based is in a extracted features will be there, then it is applied to a post processing like verification, identification. I have applied for identification as well as your speech recognition. So here the final output is, this is the output I have got. Okay, so these are the references I have taken for my preparation of my presentation. And what are the applications we can incorporate in your speech recognition is smart home, where your speech recognition, speech synthesis, along with the Internet of Things, as well as your conventional lower order incorporation, as well as your higher order controlling of your smart homes, that can be incorporated. When we go for your smart city, intelligent transportation, intelligent security, and computer vision based data analytics, as well as big data analytics, along with this we can incorporate your speech. When we go for healthcare, I have already mentioned natural language processing, NLP will be the predominant scenario. NLP, along with the NLP we have to use LM models, and your disease recognition and drug development, drug based drug drug dosage injection, that can be identified with the help of you. So these are the AI approaches. And when we go for your technology oriented scenarios, intelligent tutors, your different language learnings, that can be incorporated with your speech in order to provide your overall application. So with that scenario, I think I have handled some of the basics of your speech recognition. And once again, I thank the convener, Dr. Rajesh sir, and coordinator Kavita ma'am and Marial ma'am for their patience and their opportunity they have provided to take the initial session of that 5 days virtual FDP on design challenges in antenna RF devices for next generation communication. Thank you once again. Thank you, everyone.
Thank you, sir. Thank you, Dr. Karthikeyan, for giving his valuable insights on speech signal processing using modern AI approaches. The deep neural networks, like convolution neural networks and reinforced deep learning, improving intelligibility for hearing aids and voice assistants, separating noises and signals to enhance the speech processing and information has been shared by Dr. Karthikeyan. Now I ask the participants if they have any queries. You can ask, sir. I think there is no questions from the participants. I think, can we end the session?
Okay, ma'am. Okay. Thank you. Thank you so much,
Thank
ma'am.
you, sir. Thank you for sharing your valuable knowledge.
Thank you.
Thank you,
Thank
sir.
you.
Thank you. Feedback link will be provided at the end of the session, at the last day.
Participants in the afternoon session link will be shared, and it is from 2:30 p.m. to 3:30 p.m. Thank you. Thank you.
Hello, good evening. Am I audible, ma'am?
Yes, sir, you're audible. Just let me start the session. Participants, so I'm excited to share the highlights for 5 days FTP. So the afternoon session starts now. Let me introduce the resource person, Dr. Saktivel. He is a senior member of IEEE, received his bachelor's degree in EEE from Madras University in 2000 and master's degree in applied electronics from Anna University and PhD degree from Anna University. Currently, he is working as a professor and associate dean for School of Engineering, Department of Micro and Nano Electronics, VIT Vellore, India. He has worked as visiting professor in Tor Vergata University of Rome, Italy. He has co-authored many books and he has many publications in VLSI design and basic electrical engineering. He has delivered more than 70 keynote and guest lectures in various universities across India and overseas. His research interests includes advanced digital system design, low power VLSI design. He has heading VLSI division of VIT Vellore, and he has set up a system on chip design lab also in VIT University. He is also a consultant trainer for Texas Institute and Bose Lab, Bangalore, and Wipro, Bangalore. He has received ICTP fellowship sponsored by UNESCO for attending international workshop on SOC. Being conducted in Doha, Qatar. He has mentored more than 300 UG and 60 PG, and also he is supervising 10 PhD students under his guidance. So I have a great pleasure in inviting you, sir, for the afternoon session. Thank you, sir. So you can start your session.
Thank you, ma'am. Thank you, ma'am. Can I share my screen? Ma'am,
Yes, sir,
can you
share
make
the screen.
presenter?
Yes, sir, you can share the screen.
So, very good afternoon, professors. First of all, I would like to thank PSN College of Engineering and Technology for inviting me for such a wonderful session. And congratulations for the rest of the speakers where you have planned for next couple of days. I would like to thank the principal head of the department and different professors who have been assembled here for this particular session. Of course, this session is quite challenging for me. Probably, I believe all professors, maybe you might be knowing what is the biggest challenge after having a session post lunch. So, in spite of that, I would like to take you through a couple of areas where you would be already familiar with. But my intention is to go ahead in the aspect of this radio frequency devices, what could be the next possible changes, and what are the challenges in fabricating those RF based device communications, establishing that, and what could be the different directions in which the researchers as well as the student can pursue their research or in term of where the projects could be carried out. Keeping that in view, I have framed this session. Of course, the slides for this has been picked up from different sources. I'm sorry that some places I would have cited them, some places I might not have, some of the very basic things, so I have left. So all over the presentation, I have cross-referred some of the IEEE and the Springer elsewhere paper. I have also included that too. So for the next some 50 minutes, I kindly request you to be with me. And some topics, if that is going to be an overlap, kindly excuse me to have a holistic understanding on the homogeneous crowd. I thought it could be starting from the very basic, right? So presently, different researchers are different all over the world. If you look at, there is a grave requirement on particularly this RF based communication and RF based device. Probably you might be aware of the evolution of communication starting from 2G, 3G, 4G, 5G, now 6G. But if the question is, have we really explored the 5G communication holistically? Are we using 5G equipments? Are fully exploited this 5G communication? Most of the times, the answer is no. Recently, last week, I had an opportunity to visit Nokia, which is in Oragadam, Chennai, where I happened to go through only the radio-based communication devices manufactured at the fab. The complete factory visit I made it. What I understand, the real challenge is most of the time I hear from them, around 80% of the equipment which they use for radio manufacturing, all those things, has been catering the need of 4G. Coming to 5G here and there, they have started, but I don't think it has extended or it has been completely used to the greatest extent, except a very few country wherein they have completely exploited this 5G. Now the real question is, what is the real challenge in making this 5G? What prevents them in moving towards complete usage of 5G evolution? What are the real challenges in that? That's what we would like to explore on this. So probably you might be knowing, when we speak about radio frequency, particularly the frequency band lies somewhere from 3 kilohertz to somewhere around 300 gigahertz. Now the question comes only here. Of course, the frequency, after the boom of semiconductor mission come into picture, now um, the frequency, even if you give 1000 gigahertz frequency, terahertz frequency, I'll be happy to do that, because there is no end for making a system to be ambitiously too high speed computing. I wish that no, the speed of the communication which takes place or from one place to other via wireless should be at the ultra high speed, right? You can't even imagine. I mean, I don't have any bar on that. Okay, I am quite satisfied with 2 gigahertz, 5 gigahertz, 10 gigahertz. No, day by day, the computational frequency, the demand for computational frequency is also keep on increasing. If you try to look at why, because the accumulation of data, that to this, after the AI and ML come into picture, probably there is a grave requirement of no, a huge data manipulation working on that prediction. And unanimously, this AI ML become a part of every field. You can't. It become the mother tongue of almost every sector of engineering. Not only engineering, medicine. I don't think it has left out any domain untouched where AI ML become a part of it. If that is the case, nothing wrong in that. But the headache comes in terms of data manipulation, data computation, data prediction, working on the huge volume of data. When I speak about huge volume of data, obviously the requirement for that also increases multiple fold. I mean, the data transmission also becomes multiple fold. So naturally, if it is only an voice-based communication, I don't think much about it, because the band of frequency which I require is quite less. So I'm quite convinced with the rate at which the data transmission takes place. Rather, if I am speaking about an environment where a real-time high pixel camera is capturing a real-time game like cricket matches, something like that, and I would like to transmit to the other side of this world, then naturally what I feel, like I am expected to transmit a huge volume of data from one end to the other end, particularly without any delay. When I say delay, it doesn't mean the delay should be in seconds or no milliseconds. I speak in terms of femtoseconds, picoseconds, or even less than that. Why? Because electronic industry, particularly IC industries, even a pico femtosecond could make a drastic variation in the overall computation, and that too after bedding come into picture. So even a picosecond variation in the predictions or a delay in the transmission of data could lead to an enormous illegal activity of predicting that. So naturally I have been forced to go ahead with a high speed computation wherein which demands somewhere around 100 gigahertz. Okay, I am quite justified with no usage of or this use case for say 200, 300 gigahertz. But the real question comes, how am I going to make this workable? Because when I say I am going to operate or I am going to transmit a data which is supposed to go at a speed of, say, let's assume 200 gigahertz, the real problem comes when it is going to get synthesized in the form of a circuit or a board, say a power amplifier or some sort of mixer or some sort of oscillator. When I want to operate those devices at gigahertz, naturally, I am finding a huge problem in that. What's the problem? Basically, the devices, their operating frequency are in the range of megahertz, and their frequency doesn't goes to the extent what I am demanding for. The operating range of the frequency doesn't go to 300 gigahertz or 200 gigahertz. Now, this is where the challenge is. I wish my system should operate at 300 gigahertz, but the devices which I use for fabricating this 5G are not in a position to support this 200 gigahertz, 500 gigahertz, 300 gigahertz, or 100 gigahertz. If that is the case, then I need to think about some other scenario where the devices, material sciences should also be equipped to operate at this higher range of frequency. This is what I said. The normal MOSFET, which is used for IC fabrication, doesn't go to the operating frequency of somewhere around 200 or 300 gigahertz. So naturally, it becomes a bottleneck. Though I claim that my system can go ahead, on paper, this can work with 5 gigahertz. 5G with a range from 3 kilohertz to 500 gigahertz. On ground, on implementation, I may not be able to run this exhaustively up to this whole band of frequency. Now, that's where I said, when you come for 5G implementation, the real challenges comes in the equipments which are used for establishing the 5G communication network doesn't have the capability to operate at such a higher frequency. Then what should I do? What are the way forward? How could I work on this? This is what we would like to think about. Okay, our real challenges which comes in front of implementation of 5G or 6G, and unfortunately, um, you people might be aware of, without getting too much of geopolitics. What we understand, most of the equipments which have been used for fabricating this 5G, 6G are available with our competitors, particularly China, US, all those things, wherein it also demand the need for no, the materials which may not be possessed, or the rare earth metals which are not possessed by India. Or even if we possess, the pathetic condition is India doesn't have the technology to extract that from the ore and establish a connectivity, something like what US as well as America has done. So they have potentially explored the market for 5G equipments, as well as 5G equipments that need to be get manufactured. Today we become a dependent on that, and that too, the equipment also okay, but bringing back the equipment, another infrastructures that need to be the ecosystem which need to be created for 5G literally fails. So it doesn't matter, like it is like I'm having a bike which can run at 250 kilometer per hour, but the problem is my road doesn't permit more than 80 kilometer per hour. Then it literally, there is no point in having a bike which can go with the 250 kilometer per hour with the road which doesn't permit me greater than that of 80 kilometer per hour. That's how we become a bottleneck all over. Yeah. So, usage of antennas, transmitters, receivers, particularly in the radio frequency band, can be used for various wireless communications, broadcastings, all this. Now, as I said earlier, this radio frequency, particularly, they have captured a huge market, particularly with cell phone, radio, televisions, Wi-Fi, and all mode of wireless communications, Bluetooth, satellite communications, particularly the event of autonomous cars or the automobile sectors, after this has boomed out, uh, the huge grace for wireless based devices or wireless based communication protocols came to a greater need, starting from Wi Fi, all this. And not only that, it's more like device tracking wherever you need. Obviously, we are looking forward to come up with an infrastructure which supports all this wireless based communication, which operates completely on the RF spectrum frequencies. And the real challenge, apart though I haven't mentioned here, the real challenge here is particularly the power consumed by RF devices. I know it's a power hungry device. Radio frequency devices are the infrastructures which has been used for 5G communications are really power hungry. So I need to think about how to quench this thirst, or how could I come up with a better design which will have a low power. Say it could be a power amplifier, it could be a mixer, or it could be an oscillator, or it could be a PLL, which is being a part of this radio frequency infrastructure equipment or the ecosystem. I'm supposed to think about the power. And not only that, the antenna which I'm supposed to use for this antenna area is an important matter. The third thing, as I said, the frequency under which it is going to operate, or the speed or the performance on which these metrics are going to be operated. Okay. So, as you are aware of RF frequency divided with various ranges and bands, all this, like I'm just quickly moving ahead. Probably, as I said, this is something what you could see here, the different band of frequency and their application. I believe you could be aware of this, particularly radio frequency starting from 3 kilohertz to different range. As I said, somewhere when you cross 3 gigahertz to 300 gigahertz, though on record we say that it is supporting all this, but definitely we don't have such a huge frequency supporting equipments wherein we find really tough to navigate on this. So you might be aware of millimeter wave, all those things. I'm just skipping it out. And the basic infrastructure for any radio frequency ecosystem, we could see like starting from transmitter, receiver, LNA, filters, amplifiers, power amplifiers, antenna designs. So I would like to see quickly going through a couple of things. You might be aware of transmitters and receivers. So basically it is designing a transmitters and receivers on both the end becomes really a toughest job. So having said this, you have to come up with a device which is supposed to be transmitting the electric as well as magnetic field radiation. So you could see here, we have a voltage source which has been generated, and it creates the voltage set either up current and down current in the antenna. Based upon this, it generate an electric field and a magnetic field. These radiations are being transmitted all over, and at the end, this electric field, the field induces currents and voltage. Therein, this has been passed through a receiver antenna. So this is a very simple, brief outset of any transmitter or receiver. But a detailed look of transmitter and the receiver tells us multiple things, ranging from what sort of equipment we need to use, and what should be the radiation that need to be radiated, and how long it should be, what should be the testing metrics that it should follow. So this is what, though I have given that as a conceptual diagram, internally, this transmitter and the receiver requires a huge amount of ICs, which is operating with very high power, right? So in short, this radio frequency processing equipment, both on the transmitter side and the receiver side, which is supposed to work with the baseband modulation, all this, right? And it get transmitted via this antenna, wherein the next important challenging part with respect to analog portion is, one is the interference and the other one is noise. This is the real challenge for us because, say, if it is in a digital environment, it is quite easy to suppress the noise or the mechanism that is being followed for suppressing the noise in the digital equipment or the digital environment is quite easy. Whereas when I come to analog environment, the real challenge starts there because it is a multi-dimensional optimization parameter. When I'm trying to optimize one parameter, say with respect to frequency of operation, then immediately the bandwidth may go out, or the signal to noise ratio may fail, or the operating range may fail, or it could be with high power consumption, or it could be with the area. So um, as far as digital environment is concerned, my objective is very simple: performance, area, and power. When it comes to analog, this is for digital. When it comes to analog, the scenario is quite large. I might be having um, end-to-end swing, signal to noise ratio, power, power delay product, and then bandwidth, peak frequency, operating range. Like this, you have multi-dimensional optimization parameter. So naturally, for a designer, it's more like a complete. That's why people say always coming up with an analog design or something like a mixed signals design is really a challenging, and that to bring that on a single IC, that's a real challenging job, right? Okay. So that's how for a system building as a transmitter and a receiver, we really have a problem with that. And on top of this, as you are aware that all the RLC components, impedance matching becomes an important issue while you take up a design, and particularly when you want to. So you might be aware of when does the maximum power transfer theorem takes place. So unless the impedance matching takes place, you may not be able to tap the signal which has been transmitted from the transmitter on my receiver side. So the real challenge is building up a system to have a perfect impedance matching on the either end in order to ensure that. So under that case, I am expected to come up with this RLC component, their impedances, and what could be the impedance matching that need to be provided. One important thing is, if I am today, you work with something called as what a system on a chip, SoC, which means the complete system is being incorporated on a small chip. Now, when I speak about system on a chip, I go for chip for multiple reasons. It's very compact, area less, high speed, all those. It becomes elegant, small. It could be anywhere located, reliable. All these stories I can speak about. But coming to incorporating this inductance and capacitance, it really becomes a challenge for bringing capacitance and inductance inside the IC. And that too, to a very small value of capacitor could be easily brought in the IC chip or as a part of the circuit. But when you speak about the inductor, it's really tough wherein we don't have technology, or the technology whatever we have, it's really a toughest or costly affair to bring that on a SoC chip, system on a chip. So impedance matching becomes an issue for a system like RFIC design. So particularly as a VLSI design engineer, if you look at the people at Qualcomm, they used to blame only for this. Of course, a filter becomes one of the important portion in all over your design, particularly RF-based equipment design. So you have a multiple variant, the corresponding test. I mean, what sort of devices, circuits which will be used for different bands filter. Say it could be a band pass, a low pass, high pass, whatever you say, right? And correcting their poles, zeros, all those things. I'm not getting too much into that. Probably all this becomes a part of it. The point which I would like to highlight here is, so when we speak about the radio frequency equipment designing, what I want to point here is internally the designs which have been used to operate, particularly with respect to filters and impedance matching, the effect of R, L, and C becomes a major issue. And how do we bring that on an onboard? And how do we make that to operate at a very high frequency? These are the two real challenges which we have it. Right. Then, yeah, of course, the Q factors. Of course, this is one of the important metric which the selectivity parameter Q factor. With respect to RF design parameters, this is one of the important parameter wherein we need to be taken care of. So when we say Q, again, that's being decided by only L and C, right? So this reactive components, particularly inductance and capacitance, we need to make sure that how efficiently it can matched and what sort of resonance circuit it is being built with. Again, this, it could be a parallel, it could be a series, all those things. Not getting too much of this. And coming over to RF based, as I said, it could be an RFIDs could be of either active, or it could be passive or semi-passive, based upon whether it has its own active source or not. And their applications compared to that as near field communication has been cited over here. The objective of this is, what we try to say is, when we have an RF based equipment communications, we would like to have different types of equipment. Either could be an active, which generates energy, which has its own energy source, or it may be a passive device, and how it is going to transmit and get the information done. So again, it's a mere comparison of RFID and the near field communication, wherein the frequency band, what sort of modulation they use, what is the data rate, what is the range under which it works, what are the popular use cases which we have, and the standards. Again, these are the different area of application. And again, as I said in the beginning, RF has almost occupied every sector of the human life. Starts from space to day-to-day communication with respect to hospital, particularly health sectors, retail sectors, IT sectors, vehicle tracking, and space vehicles. Everything becomes a part of it. Now, next comes a few more on LNA. Probably you might be aware, low. This is one of the important component in your RF design circuitry. Low noise amplifiers. Of course, it is an amplifier. There's no doubt about it. So what happens here is, when you look about LNA, it is the circuit which amplifies low power signal without significantly degrading its SNR. This is more important. Whenever you want to amplify a signal, right? So the real problem is it will amplify the noise too. So because, say, suppose this is my LNA in our RF circuitry. So while it is amplifying the signal, it also amplifies the noise with respect to that. Not only that, when you take a signal to noise ratio, of course, the amplification factor divides the power of this signal to the power of the noise, becomes the final component. But beyond this, you have one more component wherein this low noise amplifier is completely made up of active devices like transistor, MOSFET, resistor, inductor, all this. Any active devices which is quite an operation will generate a noise for it. Now, this noise will also become a component wherein now this is the real challenge for SMR. Now, how do we come up with the design of LNA, which is supposed to provide me a better SNR, right? In spite of having an active device in my LNA circuit. This is the real challenge for this. So it's not the noise with the signal, it is the noise which comes because of this active devices used in an LNA. This need to be sorted out. There are many research works which has been carried out. Till date, you could see 1 or 2 papers in every transactions which could address the LNA design for the applications of radio frequency applications, RF applications. So what are its requirements? Low noise, of course, it's my priority. Linearity, low power, low area, high gain, matching with respect to antenna or filter. So it's really a toughest job. As I said, it's a multi-dimensional optimization parameter. If someone would come up with all this being optimized, then really that would be the best. But sad part is, it's always a tough thing to optimize all this. Then comes the mixer. Probably this RF mixer, if you take, it's a 3-port device, active device that can modulate. So you could be, I mean, you are aware this modulation, demodulation techniques, wherein the frequency changes the frequency of the electromagnetic signal without changing or without or preserving the phase and the amplitude of the initial signal. So probably you could come for up conservation or down conservation. So probably the purpose of the mixer is to enhance the frequency, right, of an electromagnetic wave and transmit them from the sender side or from the transmitter side, and again go ahead and get back the original signal at the receiver side. When I say oscillators, you are aware that there are multiple ways of creating an oscillator. Basically, an oscillator is a circuit which produces oscillation without having any sources of power in that, or sources of input. It has a power line, but it doesn't have any input. That's why we call this oscillator as zero input, which will produce oscillation. Basically, if you look at the architecture of RF transmitter or at the receiver side, you could see there will be a local oscillator, a mixer, and an input signal. Right now, the important point is how to design these local oscillators. There are multiple ways to design these local oscillators. Basically, it could be done by a PLL network, a phase lock loop network, which is again being designed using this VCO, voltage control oscillators. Right? Possibly you are aware that a PLL is a circuit used for either upscaling or downscaling a particular frequency and is used to track a particular frequency whenever. It could be used in radio tracking or it could be used for frequency synthesizing. This is how we use the PLL. The complete PLL architecture itself is a separate study, right? Coming up with a proper PLL with good tracking ranges, designing them is the biggest challenge for us. Okay. Now, how does the PLL works? So probably you are aware of, so this is my VCO, this is my reference oscillator. So the main difference between these two, in fact, when I say a reference oscillator, an oscillator is an equipment which is going to generate, or electronic circuit which is going to generate a constant output frequency, correct? Which is more stable, right? But what is a VCO? VCO is a voltage control oscillator. It is almost like an oscillator only, right? So here the input is voltage, the output is the frequency. That's the quite interesting part in this, right? The input and output parameters are different. My oscillation is being controlled by a voltage. That's why we call this as voltage controlled oscillator. Now let's look into this. How do you get this voltage separately? And this frequency is the one which it is generating. Now the real question comes in. See, you have an reference oscillator and you need a constant frequency oscillator. Why do you want to go with all this PLL? Rather, you could use this stable oscillator as itself as a reference for your local oscillator. Why do you need a PLL here? That's what the question is. Are you getting my question? You have an oscillator, which I use it in my PLL network. Again, what is the purpose of an oscillator? It is going to generate a constant output oscillation. It could be using a crystal or whatever, right? So noticeably, that is the one oscillator which keeps on generating with the standard output without any degradation. The argument is right. You can use this reference oscillator in this local oscillator, but the point is only here. These local oscillators are being constructed using this crystal oscillator, wherein at the maximum it may go somewhere in the range of megahertz. But unfortunately, what I need for RF application is in gigahertz. So I may not be able to construct a local oscillator or a reference oscillator with the gigahertz range. But what can do is, VCO can generate high frequency oscillations. Say it could be in 2 gigahertz, 5 gigahertz, things like that. But the problem with that is, it won't be a stable oscillation. It's more unstable at this VCO. Now the real challenge is, it is something like this. VCO generate high frequency oscillation, but it is not stable. Reference oscillator generate oscillation. It is stable, but the frequency range is very less. Now, here comes a PLL architecture to do this. What we try to do here is, this high frequency has been scaled down by or divided by n times, and that's being connected with a phase difference or a phase detector. It will detect the phase between these two, that is the reference oscillator and this. That phase difference will be passed on through this amplifier, and because the phase difference is very, very small, so we would like to amplify that. So an amplifier will be a part of this PLL. Following that, it will get filter, which means I would like to suppress high frequency and I would like to take only the low frequency value, low pass filter. From this filter, again what I'm doing, I take this voltage signal and this is going to be the control for this oscillator, which means whenever these two frequencies are same, then the control voltage for this VCO is constant. When the control voltage for VCO is constant, it produces a constant output high frequency signal. By any means, if there is a deviation from these two, then appropriately this control voltage will vary and make sure it will try to produce, the variations will be taken care up to a certain range, what you call it as a track range or lock-in range. Up to that, it tried to generate a constant high frequency oscillation signal, which is used for tracking any radio applications, or it could be any of this. So this is where the real challenge is coming in. So designing this VCO, of course, we have seen what is a local oscillator. Local oscillator is quite easy. Designing a VCO and making sure that it is tracking your biggest job, right? And top of that, VCO is being affected by the temperature and noise. Whenever an external temperature and the noise is being a part of it, it could lead to instability in the VCO output, and it could produce an unstable output. Under that case, we need to make sure that it is much more stable. So these are the biggest challenge with respect to building up a PL network, right? Of course, an oscillator could be of different variety you might have come across. It could be a positive feedback network, very simple feedback oscillator, or it could be a negative resistance oscillator, simply a tank circuit which could have L and C, wherein the resistance will be a negative resistance. But all this, again, the real challenge is creating a high frequency is the point of matter to us. So F of T, the best way we could go ahead with voltage control oscillator, F naught plus K times Vn. This is where I said the Vn is my input voltage. It is being used to control my frequency and output. So thereby it tried to keep a constant output based upon this Vn, and F is the frequency output. It's an interesting circuit where you can even construct this circuit and visualize this. Whenever the whenever the control voltage varies, if you take the transfer function of this, you will understand this. The input dimension, the input is voltage, the output is frequency. So I believe this is where. So let's assume that this is the reference voltage or reference frequency. This is being generating, and this is the feedback which comes from this frequency divider. So you have it. There is a small phase difference between these two. This phase difference becomes the pulse which will be fed to this amplifier, and it get amplified and filtered. Further on, it is being given to this VCO. See, the VCO voltage will be something like this. Can you see here? It's like a small, minimal, almost like a constant DC voltage. This is the one which is used for feeding this VCO, which produces a constant, stable, high frequency signal. In fact, you can construct the whole circuit and see that in the simulation as well as in the hardware. I recommend probably the people who, I believe it could be a part of your task, where a VCO can be built and you can find out what is the capture range, track range, lock-in range, all this. The next important component with respect to this is power amplifier. In fact, it is the last stage of your transmitter, wherein say it's not like a normal amplification of the signal is required. That may be quite sufficient to run the internal circuitry. But for transmitting, I really need to boost this power of the signal so that it get transmitted or it is airborne waves. So to do that, definitely I need a power amplifier to do this. So a power amplifier which could amplify the signal or boost the power of the signal so that it get transmitted. Designing this is a real challenge at the other end. So what are the metrics associated with that? Of course, you need to think of gain, power, bandwidth, efficiency, linearity, input-output impedance matching, heat. All this becomes an important metric on the transmitter side. So a designer need to take care of all this. Modulation, as you are aware, there are multiple, modulations starting from analog side to digital side. So it could be, you are aware of this, right? So you have an input signal, you have an oscillator. Input signal may not have the high frequency, but when I try to transmit the signal, it gets faded away. So it can be transmitted to a long distance. So what I try to do, I try to bring that on a carrier, which is of high frequency. The high frequency is being generated by an RF oscillator. Correct. So based upon the amplitude, you call that as amplitude modulation, frequency modulation, phase modulation, all this. When it comes to digital, you have amplitude shift keying, frequency shift keying, phase shift keying. Correct. So without getting it too much into that, let me move on. And so what I understand, we have different component which is supposed to be generated. So on a holistic understanding, when I want to make a radio frequency or a 5G ecosystem to make that radio frequency communication to be much more effective, I have multiple components which need to be circuits which need to be designed with utmost care, which could take into account of frequency, amplitude, time, signal to noise ratio, power consumption, all this into account. So what could be the way forward? How do we do that? So for that, we have come up with, till date, what we use for like IC fabrication is your silicon, right? Silicon has been used very widely. Almost all IC you could see silicon happen to be the base material, and MOSFET is a material or is a device which is used for fabricating all our electronic circuit. Now, particularly with the mobile phone, with the latest mobile phone, it has been switched over to FinFET devices, which is operating with a little more higher frequency and low power consumption. And FinFET, most of the devices, latest mobile phones, they have some of the devices or some of the mobile phone models has been manufactured using FinFET technology. It has fine control, low power consumption, and the frequency of operation is also better than that of the MOSFET. Right? So, like this, what could be the alternative in the place of silicon? Of course, silicon, remember, silicon has ruled the IC fabrication for the last more than 30, 40 years. So, the fabrication setup which has been used for manufacturing this electronic equipments used for communication, all the communication devices, they have a processing setup for silicon. Now we have reached a point where we need to switch over to the next level. So we are looking at what could be the alternative. So out of that, we have different material, what you call it as a gallium nitride, like this silicon carbide. People who are looking with the materials, you could see aluminum nitride, gallium nitride, hemp devices, like this. People speak about different types of materials which could be used for fabricating these sort of RF communication devices which will operate for a higher frequency. So the whole idea is now on the research side, people would like to move over from silicon to germanium, all this. So this is the paper from Triquant Semiconductor, right? So where this explores what is the possible mode of replacing the silicon with gallium nitride, which could be the next generation electronic devices. Of course, it has discussed the pros and cons of it, and how do we come up with the depletion mode, enhancement mode of normal thing, whatever we have with the MOSFET which you operate, silicon MOSFET, what you have it. So I wish you can go with this paper to get more insight on what are the different ways, or what could be the potential replacement of silicon with this gallium nitride. There is one more paper which explores the possibility of lithium neobed using thin film devices for next generation wireless communication. It's again, right, explores the possibility of lithium neobed. Again, remember, this is a rare earth metal. So whenever I speak about some new devices, most of the devices or the material happen to be the rare earth metal. The worst part is the availability of rare earth metal. Today, the world is running behind hunting of this rare earth metal. Whichever nation has this rare earth metal, particularly with respect to semiconductor industry, they are going to rule this world. Right? Once upon a time, oil was the whichever country which possesses the oil becomes the richest country. Today, whichever possesses the rare earth metals, they become the richest country, or they become the dictators. Probably, if you would have been following the geopolitics, you could understand the rival that took place between US and China. The moment US said that we are going to give much more sanctions on China, immediately China went on with cutting the supply chain for rare earth metal, which happened to be the lifeline for US. So the next moment, they started revoking that. So such a very important thing, right? And so you could see almost the whole geopolitics revolve around this rare earth metals, or which is the country which is going to lead the and next generation of communication with their devices. Right. Again, there you could see multiple such papers which has been discussing what could be the potential of replacing silicon with gallium nitride, things like that. So they claim that low cost mature processing with respect to silicon can be replaced with gallium nitride. So, and one more important thing is an interesting study in this paper itself. You could see what is the potential market of gallium nitride in the radio frequency marketing size. So 2017, what you could see, 40% of that were being used in telecom sectors. And this has drastically increased to 43 percentage of telecom sector coming to 2023. So day by day, you could see the telecom industries or the communication sector get more amount of IC chips, which is facilitating the radio frequency communications. And one more important thing, when you make a cross comparison between the existing silicon with the gallium nitrate and gallium arsenide, what you could interestingly notice the band gap. Right? So the band gap for gallium nitrate is 3.4 and this is 1.4 compared to that of no silicon, it is 1.1. And look at the mobility also. This is around 1350. This is 1500 and this is 8000. Definitely, we could see gallium nitrate and gallium arsenide would be a potential high frequency application equipment where we struggle a lot with silicon in the aspect of radio frequency equipments. And one more important thing, which I would like to touch upon is, see, when the advancement in radio frequency or baseband increases, finally, end of the day, it becomes a chip. That's what you need to understand. Or any sort of the RF communication, it could be power amplifier, or it could be an amplifier, or it could be a PLL, or it could be a mixer, whatever it may be. End of the day, it is a simple chip. When you take a chip, there is an intercommunication, which is nothing but a wire, which has been used between different components inside that IC. Now, two important things become important. I mean, two important things is supposed to be grabbing the attention of designer. One is intercommunication and the intra-communication, which mean you have one more IC, communication between the IC become intercommunication, inside the IC becomes intra-communication. All this has been used with the wire, metal tracks. We used to call that as it could be a metal, aluminum metal, copper metal, gold metal, silver metal, anything could be there based upon the requirement. This could be the metal tracks which is used for connecting wire bond. Right? So when you have these these metal tracks doesn't scale in the same rate of the MOSFET. To understand this better, you have a MOSFET for fabricating all this IC. Previously, we had somewhere around 320 micrometer. Now this has been scaled down to 2 nanometer device. Right? You see, look at the scaling. Just within this 15, 20 years, this has been the scaling of the device. But unfortunately, the interconnects that has been used for doing all this doesn't scale in the same fashion where the device has scaled down. So this has led to a huge amount of interconnect inside an IC. Now we need to think, it's high time to think about a potential loss that is taking place on the interconnects which are being used inside an IC. Either it could be within the IC, intra, or it could be intercommunicating between the chip. So there are many solutions which try to discuss this, particularly while you operate with high frequency, like 100 gigabits per second, or while you are planning to transmit a huge volume of information, then definitely we need to think about what should be the better way to come up with better interconnects. So this paper discusses about all that, particularly with the time division multiplexing, TDMA, and how to establish that, CDMA, bond division multiplexing, all this. So this is also where you could say this is interconnect, metal bar interconnect. So it's a one-to-one communication more of this. But what people suggest is you can go for multiplexing via this method, a single wire track which could be used for multiple way. The next important one more highlight is with respect to packaging system. That is what you call it as a wafer level packaging, WLP, wafer level packaging. After the IC or the silicon wafer has been made, you need to connect to the external IO pads. This is being done by wire bound pads, wherein this method is called as a packaging. Now, packaging becomes a toughest job, particularly for 5G equipment, millimeter wave applications. So here, new sort of packaging styles has been for Qualcomm, Broadcom, Skyworks, all these people, because they are the major player with 5G equipments. So they follow this SIP, silicon in chip, silicon in packages, SIP, silicon in packages. They come up with a better way of packaging which could eliminate or shield this electromagnetic interference, and which could also go for a heterogeneous integration of different segments on a same IC without compromising on the speed by providing a high degree of isolation. So this packaging at the outside, it seems to be not a big concern, but when once it comes with the 5G devices, fabricating of 5G devices, right, then definitely it is a main focus of our concern. In fact, most of the communication equipment, their package becomes an important concern. So based on that, this paper were been given by, there are multiple data produced from Qualcomm, Broadcom, all these people. And how are they making the complete chip on a die is being discussed here. Real challenges with that. Then comes compact low profile MIMO antenna portably. So this is also like how to design particularly portable devices. Portable, the size should be very, very less. That's what most of the application, the antenna design. One important thing that need to be taken into consideration for wireless 5G wireless communication is making that as a portable. So in fact, this paper discusses about how to make an area efficient portable devices, something like that. Then at last, what I could see here is how to use this machine learning, right? Machine learning for developing this antenna. In fact, today, as I said in the initial case, machine learning become an important one for being used at different domains, design of different domains. So that has not left this communication also, like particularly on RF based communication devices. So here we use a data sets which has been already given for designing this UWB antennas using this machine learning model. They are used to predict this reflection coefficient, S11, which will be very much helpful in designing the direction and the energy in multiple cases. This helps a lot. So this paper make a thorough study on usage of machine learning for generating next generation communication antennas. So in fact, a comparative analysis has also been made, and this UWB antennas, which could be used for different sectors, right, from transportation, then smart homing, wireless communication, patient tracking, and all different sectors, right? Then how did they use this machine learning models? So basically, they were capturing the data with respect to parameter tuning, operating band, substrate selection, impedance matching. All this has been part of this antenna design, and then those data has been used for machine learning models training set, and this has been imported as a part with respect to Python library, and the evaluation has been done. From that, the best model is being chosen for validation. So thereby, it predicts the S11 values also. So a comparative result has also been given with respect to different machine learning algorithms like decision tree, then random forest, KNN, ANN, extra tree, gradient boost, XG boost, something like that. From different machine learning algorithm, it has been cross-compared and validated. So that's all from my side. Given this 1 hour, I try to give a topmost overview of what are this different component, how essential that has been used in RF communications, and what are the real challenges in establishing that as a hardware. I am available in LinkedIn via this under the name Shaktivel Ramachandran, and most of my I used to put that my papers, conferences, workshops, all those I used to do that. And this is my Google Scholar, paper citations, all those things, and ResearchGate. I'm also available in Facebook under the name of VLSI Shakti. Thank you all for being them for such a great 1 hour. Thanks for the wonderful opportunity. Once again, I would like to thank you.
Thank you, sir. Thank you for your beautiful presentation. Sir has well
Thank you.
explained for the next generation communication with the challenges with the IoT integrated devices, how the communication design challenges has been well addressed. So now the thing is we have to integrate machine learning with the antenna design. So for that algorithms that also has been discussed by the sir very well. Now I request the participants, if you have any queries, you can ask Shaktivel sir.
I wish this would have been a small insight into the presentation. Maybe the people, the professors, or the students, scholars who are working, maybe take this as forward, and you can fine tune your area of collaboration and work. So mostly I work with VLSI, working on different spectrum for different applications targeting couple of my
Yes,
paper.
sir.
So
We'll be wishing to collaborate in future,
it's my pleasure.
expecting the collaborations for the future projects, sir. Thank you very much for sharing your knowledge and sharing your valuable time for making this afternoon session a beautiful one. Thank you, sir.
Thank you. Thank you. Once again, thank you all for giving such a wonderful opportunity. I wish you all the best. Thank you.